Hello explorers and welcome to another video. Today we are going to look at day 20 of Advent of Code. And day 20, let's just jump right into it. So, day 20. With the scanners fully deployed, you turn their attention to mapping the floor of an ocean trench. When you get back to the images from the scanner, it seems just random noise. Perhaps you have combined the image alignment algorithm and the input image, your puzzle input, to clean it up a little. For example, and then we have this algorithm first here, and then we have the image. So the first section is the image enhancement algorithm, and normally given in a single line, but it has been wrapped in multiple lines for this example for legibility. The second section is the input image, a two-dimensional grid of light pixels and dark pixels. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in an input image into an output image. Each pixel of the output image is determined by looking at the 3x3 square of pixels centered by the corresponding input image pixel. So you determine the value of the pixel at 510 in the output image. 9 pixels from the input image need to be considered. 5, 9, 4, 10, 4, 11, 5, 9, 5, 10, 5, 11, and so on. These are the 9 input pixels that are combined into a single binary number that is used as an index of the image enhancement algorithm. And then they show how to combine them to get the binary number. The binary number represents the decimal of 34. And then you will use this 512 characters long thing that you had as an enhancement to find your 9-bit number. And then you will have that as your character in here. So it's a light pixel in this case. The process can be repeated to calculate every pixel of the output image. Through advances in image technology, the image has been operated on here are infinite in size. Every pixel of an infinite input image needs to be calculated exactly based on a relevant pixels of the input image. The small input image you have is only a small region of the actual infinite input image. The rest of the input image consists of dark pixels. For the purposes of this example, to save on space, only a portion of the infinite size input and output images will be shown. The starting input image therefore looks something like this, more dark pixels, and applying the image algorithm to every pixel simultaneously gives the output image that obtained. Further advances in technology, the output can be done a second time, and then you get this. Truly incredible. Now a small details are really starting to come through after enhancing the original input images twice. 35 pixels are lit. Start with the original input image and apply the enhancement algorithm twice, being careful to account for the infinite size of the images. How many pixels are lit in the resulting image? And they have said multiple times here that this is infinite in size, which means that we will have a large canvas. So making this a binary thing that you can enhance is not really something that I want to get into. So I will create a class called lit pixels, which will keep the actual place. And then I want to create a bunch of these lit pixels and put them into a set, and then calculate the pixel position for each in this set. And then we can handle it as an infinite amount, even if we go to really large numbers. So that's my current thought here. It's gonna be a little bit of a hassle to get that up and running, but I think it's worth it. So I will do some work and get back to you. And we are back, and we have a result 5717. So let's see if that is the correct result. Here, put it in. And no, not the right answer. It's too high. Interesting. So I will look into this and debug some and see what I get out of this. And we are back, and I try to figure out what was wrong with my earlier attempt, and I realized that the big problem I had was with this string here, because we have an infinite amount of values, and the first one here is a lit pixel, which means if we have something where it's total darkness, that will become a lit pixel, which is really bad for us, because then we will have an infinite amount of lit pixels. So my solution to this was moving from what I had here, where I took a bunch of pixels around one pixel and then tried to figure out which lit pixels I had around that, and then return the result of that, because I have this is a lit pixel here, and it goes through and create this binary string from all the things around it, and then we'll say if this is lit or not, just returning a boolean. And I used it up here in order to figure out how many lit pixels I had around me, so I could do an easily approximation. But if you have an infinite amount of it, you have a lot of problems when you have something that flips back and forth. And that's the reason they said 2 times. So what I actually did was I took and put everything at the X and Y position of 50, and I read in at X and Y position of 50, and I knew that I have approximately 100 of them. And then I went through the list and looked if I had any lit pixels, and I added new lit pixels, and I went from 40 to 200. So I went through a lot of them. And then when I did that 2 times, and when I was done with that, I went through and checked if the pixels that I created in the last iteration here was a little bit inside of that. I went through all of them and counted them up, how many lit pixels I had, and that got me to 53, 54. I really hope that this is the right one. And yes, you get a gold star, I get a gold star, everybody gets a gold star. So we figured that one out. But you can't quite make out the details of the image. Maybe you just didn't change it and enhance it enough. If you enhance the starting input a total of 50 times, you have 3,351 pixels are lit in the final output image. Start again with the original input image and enhance it 50 times. Okay, so we need to have a larger canvas here. So let's go back to the old result here and say that we start at 100 like that. So we have a start pixel of 100. We have a max of 500. And we want to comment this one out. And here we start at 100 and we go to 500. So let's change this up. So we start at 90, like that, and then go to 200. Now we can go from 0 to 500. No problem there, like that. And we want to do this multiple times. So let's go here and say for int I less than 50, let's say plus plus. Yep. So now we do it 50 times. Like that. We have a large canvas. We can remove this last part here. And then we need to count it out. So let's do 10 pixels in, like that, and to 490. So we don't get any spill out in the edges. I think we can do just 5 pixels. That's fine. Like that. And we will count that up. And if we do that for the original, it will take some time. And we will probably have a couple of pixels. But if we have 100 pixels in every direction, we should be able to do this 50 times without creating any spillover or any issues, because we have a large enough canvas. And I believe that this was 100 in, yeah, so 100. So maybe we don't need 500, let's say 300 instead. So we will go a bit faster, and 395, 295, like that. And we are back, and we have a result for the 50 times running it. So let's see if that is correct. No, it's too high. You guessed that, and it's too high. So I have still not removed enough, I guess, of the canvas. So let's see here. Let's do a little larger canvas then, and remove a little bit more. So let's do 20 pixels there, and let's see here. No, let's keep the nope, little larger canvas, 400, and 50 here, 50 here, and then 350. Let's hope that that is. So this was too high. Was that it? Yeah. So we will keep that. Too high. And let's run this again. See if we get a lower number. And we are back again. And I actually made the canvas a bit larger. So 150, 400. I ran 400 all the way up to those iteration 50 times. And then I was thinking that if there were any craft that was building in the edges, it could build up to 50 pixels in. So I made it 70 pixels in both directions. And then we got a smaller number from 24,000 to 16,000. So let's see if that is the correct value. Let's go back here and go down here and put in 16,734. It's too low. Weird. And we are back again. And last time it was too low. The time before that it was too high. And I think I figured it out now. First off, I forgot to update this start X value, which is important. So we have some buffer in the beginning with 200 pixels. It's 100 wide, so we have 200 pixels at the end as a buffer as well. It probably will grow about 50 pixels, but we know that there can be some craft at the edges when we run 50 times. So I wanted to remove 70 pixels on each side in order to remove most of the craft that could build up. And what we got was 18,269. Nice. So let's see if that is the right solution. Yes, you get a gold star, I get a gold star, everybody gets a gold star. Nice. So we have solved day 20. I hope that you found this interesting. I hope that you learned something today. If you liked this video, give it a like. Share it with your friends and colleagues. If you didn't like it, give it a dislike. And you can share it as well. If you have any comments or suggestions that are a little bit more complex than that, leave them in the comment section down below. Or if you solve this totally different, then I'm very excited to read about that as well. If you haven't subscribed, please do that. And I really hope to see you in the next video.